Hello everybody and welcome to week 11 in geometry. As always, make sure you've got your math notebook out and you're ready to take good notes. Taking notes is going to make you a more active participant in this recording, and when you're more active with the recording, you're going to get more out of it and you're going to understand the material better. So I'm not asking you to take notes for no reason. I'm doing it to help you with your learning. So if you don't have your math notebook out, go ahead and click pause, grab it, and come back. We are going to start with a warm-up, and we're actually switching gears this week in terms of content. We're going to wrap up Unit 2 this week, take a test, and then we're moving on to Unit 3. Which is what the warm-up is going to prepare you for, is heading into Unit 3. So let's take a look at it. First, I want you to think about what is a proportion, and jot down what you think a proportion is in your math notebook. Remember, you've got the World Wide Web at your fingertips, so if you need a reminder, feel free to do a web search on a proportion. So go ahead and jot down what a proportion is, and then I've got some proportions below with variables in each of these, and I want you to solve for x in each of the proportions below. So go ahead and click pause, and then when you're ready to check your work with mine, go ahead and click play. So what is a proportion? What is a proportion? So we've got some examples down here below. So a proportion is when we set two ratios equal to one another. An example of a proportion can be 1/2 is equal to 4/8. So we've got two ratios and they are equal. Both of these, this 4/8 can reduce to 1/2. So the idea of proportions is that a ratio can be written in many ways and still be equal to the same value, such as this one right here, where both these values are equal to 1/2. That's why proportions are actually equations with equal ratios. So we've learned about proportions in the past, and I wanted to make sure everybody remembers how we solve for a variable within a proportion. So for the first one, we're going to solve by cross multiplying. So I'm going to take the denominator of the first ratio and multiply it by the numerator in the second ratio. So 12 times x equals 12x. Then I'm going to set it equal to, I'm going to do the same thing. I'm going to multiply the numerator times the denominator of the other one, set those equal to each other, 3 times 20. Cross multiplying. So on the left side, we've got 12x, and on the right side, 3 times 20, simplify that to give us 60. And then we're working on solving for x. So the last step to solve for x is divide 12 on each side. And 60 divided by 12 is 5. So the missing value in our proportion, x is going to be equal to 5. So 3/5 equals 12 divided by 20. Both these ratios represent the same amount. So x equals 5 is our final answer. For this second proportion, we're going to do the same thing, cross multiplying numerator of one ratio times the denominator of the other ratio. And so we've got 4 times 7, set that equal to. Now let's make sure when we multiply, cross multiply these two right here, the 6 times the x plus 2, that when we go to simplify, we are FOILing, we're distributing. So 4 times 7, 28 on the left. Now we need to distribute, so 6 times x is 6x, and 6 times positive 2 is plus 12. 6x plus 12. So now we need to solve for x. So now we're using our algebra skills. We need to get x alone, so I'm going to start by subtracting 12 from each side. And we're left on the right side, 28 minus 12 is 16. Set that equal to 6x. 12s have canceled out. And then I'm going to divide 6 on each side. I'm going to write my answer over here. So x is going to equal 16 over 6, which I know I can reduce. I can divide out, what, a 2 out of both those terms and get 8/3. So x equals 8/3. And guess what? You're going to be solving or using proportions, solving proportions this week. So just wanted to review how we solve for proportions. Remind us how we do that. I'm going to go on to the next slide. So if you need more time, go ahead and click pause. So what are we doing this week? I mentioned this a little bit. You are taking the unit test. We're going to wrap up our explorations on triangles. And then, because we're finishing Unit 2, this is also the last week to submit redos. This is really important. Last week to submit redos from Unit 2. And it's a fantastic way to study for the Unit 2 test. I've also got some practice tests for you to practice preparing for the Unit 2 test. And then we're moving on to Unit 3, which is all about similarity. And guess what? We're going to see triangles again in Unit 3. As we look at similarity, one of the things we're going to look at is similarity of triangles. So we will see triangles again. And we're going to start this week with session 1 and looking at ratios in similar polygons. Before we dive in to learning about some similarity, just some quick reminders. Make sure you're checking your grades tab frequently. Look for missing assignments. If you have any, submit those. Look for assignments that maybe you started but forgot to finish. Those are going to come up as missing assignments. Go in and finish those. And then a big reminder, remember you have to message me when you submit missing assignments. If you don't message me, I'm not going to know to grade those. So I need you to advocate for yourself. Let me know, just send me a quick email, say, Miss Cole, I submitted Unit 2, Session 9. Also, you need to let me know when you submit redos as well. Alrighty, so Unit 2, again, I did put in some practice tests this week into the folder for preparing for the Unit 2 test, so take advantage of those. Those are for you. You won't get points for doing those or not doing those. Those are for your advantage to help you with studying for the Unit 2 test. Review or redoing low scoring assignments. I just mentioned this on the previous slide. A fantastic way to help you prepare for the unit test, and you're improving your grade at the same time. And remember, you do need to message me if you redo any assignments. And then if you have any missing work, get that in before you take the test. And again, let me know by sending me a message if you submit any late work. Alrighty, so Unit 3, all about similarity. So what does it mean for two objects to be similar? We, in the previous unit, learned a lot about congruent triangles and what it means for an object to be congruent. So we know congruent, we've talked about this a lot in Unit 2, means same shape and same size. And we looked at it, congruent triangles, where all the corresponding side lengths will be the same and all the corresponding angles will be the same. So we talked a lot about that too. So, but now what does it mean for two objects to be similar? So take a look at our two turtles down here. They are the same shape, right? They both are turtles, same exact shape of the pictures of these, but they're different sizes. And that's what it means for something to be similar. So let's talk about what that means in terms of the angles and the corresponding sides. So if something is similar, same shape, different size, so that means the angles will be the same. So the corresponding angles will be the same. And remember, that's what that symbol here means. I've used it a couple times now. The little squiggly with the 2 equal sign, that means congruent. So corresponding angles are going to be congruent, but the corresponding sides are not going to be congruent. They're not going to be equal. Now our corresponding sides are going to be proportional. Aha, we brought in our warm-up here. So corresponding side lengths are going to be proportional now. They won't be congruent or equal anymore. They're going to be proportional. All right, so we are going to use this idea that corresponding sides are proportional throughout session 1. So make sure you take good notes here, and if you need more time, go ahead, click pause, because I'm going to move on to the next slide now. All right, so what does it mean for triangles? Let's talk about similarity in terms of triangles and polygons instead of turtles now. So what does it mean for triangles and polygons to be similar? So let's summarize what we talked about on the previous slide. Corresponding angles of similar triangles or polygons, the angles are going to stay the same. They will be congruent. So the angles of similar polygons, triangles, are always going to be congruent. However, corresponding sides are no longer congruent when we talk about similarity, but now the corresponding sides must be proportional. All right, and we know the similarity, or I'm sorry, the symbol for congruency we talked about on the other side is this. So that represents 2 things that are congruent. What is the symbol for similarity? It's just this squiggly line that's actually on top of our congruent symbol. So the symbol for similarity is this little squiggly line right here. That tells us that 2 things are similar. Two things are similar. We already talked about what congruency means, and we already talked about the symbol. So I'm gonna scooch on to the next slide now. So if you need more time here, go ahead and click pause. I'm moving on. All right. So in Unit 2, we learned how to show, prove, I should say, we learned how to prove that triangles are congruent. We know that all the corresponding sides and all the corresponding angles must be congruent. And we learned a couple shortcuts, right? We learned side, 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 angle, side, angle, angle, side. So now we're going to learn some theorems. They're actually theorems. They're not postulates. We're going to learn some theorems that will prove triangles are similar. So there are some theorems very similar to the postulates that we looked at in Unit 2 that will help us prove that triangles are similar. Ready to learn them? Okay, so before we learn about those theorems, let's see how we can prove that 2 figures are in fact similar. So how do we know that these 2 polygons are similar? So first, I'm going to look at all these angles, the corresponding angles. All these corresponding angles, they're all equal, right? They're all congruent. So we have congruent corresponding angles. That's a good thing. Now, remember, we know that corresponding sides are going to be proportional. So let's check and make sure that these corresponding sides are in fact proportional. So I know this side here corresponds with this side. They are both located between the 87 and 103 degree angles. So these 2 sides are corresponding. So I'm going to set up a ratio to represent those 2 sides. 3, 6, and then let's compare it with another set of corresponding sides. So let's look, let's say this side here and this side here. We can use any 2 sides. I'm just going with the ones that are next to each other. 4/8. Are these ratios in fact proportional? So 3/6 I know reduces to 1/2, and so does 4/8. So these are in fact proportional. Another way we can check and make sure ratios are proportional is if we cross multiply and get the same number. So 3 times 8 equals 24, and 4 times 6 also equals 24. So I know that these ratios are in fact proportional. So just a quick review from algebra. And we could check all the sides. Do they all reduce down to 1/2? They do. So we know that these two polygons are in fact similar because the corresponding angles are congruent and then the corresponding sides are proportional. So our second question here asks, what is the scale? It should be scale factor. So the scale factor is really asking, what is the number that we multiply in order to increase or decrease the size of the figure? And just to note, if you are multiplying, or if we're increasing, I should say, so if we're increasing, then the scale factor has to be greater than 1. And if we're decreasing, then the scale factor is going to be less than 1. It's going to be a fraction, like 1/2, 1/3. And if we're increasing, it's going to be bigger than 1. So looking at our figures, we're getting bigger, right? From looking from left to right, it's getting bigger. So if we're looking from going from this figure to this figure, how much bigger are we getting? Well, remember when we set up our corresponding ratios, if we were to reduce each of our corresponding ratios, they would reduce to 1/2, right? 3/6 reduces to 1/2, 4/8 reduces to 1/2. So 1/2 or 2/1 is going to be our scale factor. If we're looking at getting bigger, then our scale factor would be 2. So the scale factor here is going to be 2 because we're getting larger. If we wanted to talk about going from this figure to this figure, we're getting smaller, so our scale factor would be 1/2. So just remember that rule that when we're talking about increasing or getting bigger, then our scale factor has to be greater than 1. If we're decreasing, our scale factor has to be less than 1. And look at the ratio of your corresponding sides, and that's going to be your scale factor. So I'm going to go on to the next slide, so if you need more time, go ahead and click pause. And that's it. Let me put up our key phrase assignment. So 2 questions to answer for our week 11 key phrase assignment. The first one is, what do you need to do when you submit late work or redos? Just want to remind everybody, because I'm still having some students that are submitting late work but not letting me know, so it's not getting graded. So what do you need to do when you submit late work or redos? The second key phrase question that you need to answer is, what is true of the corresponding angles and corresponding sides of similar figures? And then just a reminder of ways to help you study for the Unit 2 test. Redo low scoring assignments, submit all late work, and try some of those practice tests that I have posted in the week 11 folder this week. And that's it. Have a great rest of your week, and let me know if you need help with anything this week.